And we'll talk about page 4, examples 2 and 3. The first one is dealing with symmetry and intercepts, which we talked about on the front, and the other one is determining if points are on a graph. So here we go. It says graph it without a graphing calculator, use symmetry and intercepts. So if we have to use symmetry, that means we have to say if it has x-axis, y-axis, or origin symmetry. We also have to figure out the intercepts. So I'm going to start with symmetry. And I have to test for all of them. So x-axis symmetry. The test for x-axis symmetry is to take the y out and replace it with negative y. So it is x minus y squared. So that has to be negative y squared. So I have to take out the y and replace it with a negative y. I put it in parentheses because I have to square it, and I need to square the whole thing. Negative y squared, if you square anything, it turns positive. So it ends up being x minus negative y squared is actually the same as y squared equals 1. So even replacing a y with a negative y leads you right back to this original equation. Okay? Oops, sorry, I blacked out the 1. So this is a yes. It has x-axis symmetry. Yes. Now we'll do y-axis. Y-axis, you replace an x with a negative x. If it simplifies down to the same equation, it has y-axis symmetry. So it was x minus y squared equals 1, so now it's negative x minus y squared equals 1. So if I want to make it back to the original, I'd have to multiply everything by negative 1, which would change that to a positive. It would change that to a positive, and it would change that to a negative. Negative. So, sorry, this looks weird. It's equals negative 1. It is not exactly the same. The signs just didn't work out there. Last one, origin. Have to switch out both. So I have to take the x coordinate and the y coordinate and make them both negative. So negative x minus negative y squared equals 1. I want it to be negative y squared. You know, the negative x, it's just not going to go back to the original. The negative y squared will go back to the original, but this negative in front we can't really get rid of without changing everything else. So it doesn't have origin symmetry. So we have x-axis symmetry. All right, intercepts. So intercepts, I'll start with my x-intercept, and my x-intercept is when you plug in 0 for y. So it'd be x minus 0 squared equals 1. 0 squared just kind of goes away, so my x-intercept is at 1. So that would be 1, 0. Now I'll do my y-intercept. That is when x equals 0. You put in 0 for the other letter. So it'd be 0 minus y squared equals 1. 0 goes away. I'll divide both sides by negative 1. So I have y squared equals negative 1. I'll square it. And the square root of 1 is not real, so there are none. No y-intercepts. All right, so we have this graph. We know it has x-axis symmetry, but this point is on the x-axis, so there's nothing for us to reflect. There's no y-intercepts, so nothing is going on here. No other symmetry. So in order to actually graph this, I'm going to need more points. I really don't have a lot of points. To get more points, I'm just going to do a t-table, pick my own x values, plug them in, get some y values. So I'm going to plug in 2, see what I get. So 2 minus y squared equals 1. Subtract 2 from both sides. I get negative 1. Divide both sides by negative 1. Square root. Square root of 1 is plus or minus 1. So if I go over 2, I have to go up 1 and down 1. And there is that symmetry. Then I'll try plugging in 3 and see if I have enough to kind of go off of there. So I'll plug in 3. I'm kind of running out of room. 3 minus y squared equals 1. Subtract 1 from both sides. Negative y squared equals negative 2. Divide both sides by negative 1. Y squared equals 2. Square root both sides. And it would be plus or minus the square root of 2, which is about 1.41. Plus or minus. So I would say that gives us enough to kind of get a graph going here. Kind of follow those points. There we go. There's our graph. If you didn't feel comfortable with that, you could do more points, like plug in 4 and 5 and get a few more points to just get some more detail. All right, example 3, determine whether the points 2, 13, and or -3, -1, -3 lie on this graph. So this graph, if I wanted to graph it, I could, and then graph the points, but the problem with that is if your graph's a little bit off, if your points are off, if it's close, it's hard to really see if it's on the graph or not. So I'm going to use algebra to figure it out. I'm going to plug in the coordinates. Plug in coordinates into equation. I'm abbreviating equation again, and see if it's true. So I think one of these will work and one won't, so you can kind of see the difference here. So 2, 13. 2 is my x coordinate and 13 is my y coordinate. So plug in 2 for x and 13 for y. So that would be 13 equals 10 times 2 minus 7. So 10 times 2 is 20. 20 minus 7 is 13. And 13 equals 13. It is true. This is a yes. So yes, 213 is on the graph. Okay, we'll try -1, -3. So plug in -1 for x, -3 for y. So -3, 10 times -1, minus 7. So here I have -3 and I have -10 minus 7. -10 minus 7 is -17. -3 is not -17. So this would be a no. -1, -3 does not lie on the graph. I was saying everything, but my video got cut off. So here is my 13 equals 13 is a yes, and my -3 doesn't equal -17 is a no for that one.